Hello, problem solvers. Hi, and welcome to the day 4 of Advent of Code 2024. And as you can see, we have a face cam today. And thanks to suggestion of one of my friends, Tushar, who suggested that I should add a face cam so that you guys can see my reaction as I see and read the puzzle. And I think it will allow you to also feel like that I'm just sitting next to you and explaining this puzzle. Interestingly, before starting this series, I did order a camera from Amazon on Black Friday, but it got stuck somewhere in the way. And what I did is this is a very janky setup, so the stream quality will get much better. Right now, I have a phone mounted and it is connected to my PC using wireless stream. So it's a 720p stream, but we will soon have a 4K stream, and it should not matter. I'm just like right there in the corner. Anyways, so yeah, let's get started with the day 4 problem. So I have not seen it yet. It's right now 11:30 p.m. in Chicago, and the problem just unlocked 30 minutes ago. So let's read the problem of the day. So it's day 4, Ceres Search. So it looks like the chief is not here, and one of the historians pull out the device and pushes the only button on it. After a brief flash, you recognize the interior of the Ceres monitoring station. This is, I think, a reference of an old puzzle. We can see it's 2019, day 10. As the search for the chief continues, a small elf who lives on the station tugs on your shirt, and she would like to know that if you could help her with her word search. Another one of those string matching today. Your puzzle input. And she has to only find one word, Xmas. This word search allows words to be horizontal, vertical, diagonal, written backwards, or even overlapping other words. Interesting. It's a little unusual, though, as you don't merely need to find one instance of Xmas, you need to find all of them. Here are the few ways Xmas might appear where irrelevant characters have been replaced with a dot. So we can see that. Let's copy this and bring it over here in our whiteboard. Check that. Reduce the opacity, increase the stroke. So we can see some of the words. So we have Xmas going here. We have Xmas going here. We have our diagonal Xmas going like this. And we have one Xmas going like this. So overall, on and all, we got 4 matches here, which means we can see that the words that are appearing, they can go basically left to right. They can go right to left. They can go top to bottom, bottom to top, and then basically they can go diagonally forward and then just the diagonally backward. And actually this will be 2 cases. So diagonally forward left, diagonally backward left. 7 would be diagonally forward right, and then 8 would be diagonally backward right. So basically 8 directions, right? Like if you see, like we can probably look into all of the directions. So this is the pattern matching problem. We have to find this word Xmas. So the actual word search will be full of letters instead. Of course, we won't have like it this easy where we will have dots. So we will have a lot of other irrelevant numbers as well. So let's copy this and try to see how it's working. So I'll just copy this one, make this a little bigger so that it's visible. And this was one of the feedbacks I got with one of the very good friends, that he was trying to review my last 3 videos on a phone, and it was fairly difficult for them to understand what's going on in terms of the problem space. So I hope I have zoomed it a bit today. Let me know in the comments if you think this is better. But let's go back to the problem. And it looks like that this sample that we have, it has a total of 18 Christmas, and that is happening. And then they have made it a little easy for us to spot this. So what I'll do is I'll just copy I'll just copy this here, and then I will also copy this just so that we can do like a quick dry run, and I will increase the size of this as well. So let's try to quickly find all 18 of them. I think I will probably do it here. It's just simpler because we are going to do it programmatically. So we have 1, we have 2 going backwards, we have 3 going sideways, we have, let's see, we have, so count 3 right now. So we have 4, we have 5, we have 6 going up. So this is always very tricky. To see. I found another one. We have 7. We have, let's go from here, 8. We have 9. We have 10, 11, 12, 13, 14, 15. We have 16 more. So let's see. 16, 16, 17. And we have the last one here. Fine, 18. So this was interesting. So we found a total of 18 questions. And I want to think, pause the video here and think about what is the approach we are following. So even when doing manually in a very constrained environment, how are we able to solve it? And how do you systematically search for a word in a grid? And then what data structures or algorithms come to your mind to solve it? So you can pause here, think about it, and let's talk more about it. So here's your hint one. And we have the last one here. Find it. 18. So this was interesting. So we found a total of 18 Christmas in it. And I want you to think, pause the video here and, think about what is the approach we are following. So even when doing manually in a very constrained environment, how are we able to solve it? And how would you systematically search for a word in a grid? And then what data structures or algorithms come to your mind to solve it? So you can pause here, think about it, and let's talk more about it. So here's your hint one, right? We can clearly see that we have 8 possible directions that we need to check from. So left to right, right to left, top to bottom, bottom to top. We are going diagonal forward left, diagonal backward left, diagonal forward right, and backward forward right. So if you think about it, what we need to do is even if you see me manually trying to find it, the one thing you observed is that I always started my search looking for X. And once I was able to find X, my general philosophy was that I would look like in all 8 directions. So up, down, bottom, right, diagonal left, diagonal right, this and this. And even if we take the example of this first X, we can see that I see left, I see nothing, I see right, I see nothing. Top, anyways, it's out of bound. Diagonal top left and diagonal top right are also out of bound. But when I start looking at the bottom, nothing. But when I look into this direction, which is the diagonal left bottom towards, we can see that I find an M, and then my next manual process is that I would look at the M, and because I have picked a direction, I will continue to be in the direction, but I don't find it. So I come back and then I look in the other diagonal direction, I find an M, and I can keep the direction same now. And then I find the whole word. And as soon as I find the whole word, I basically add to my counter, right? So does this remind you of something, right? There is a very interesting concept known as backtracking. So what we are doing here is we are starting from one element and we are going in all possible directions. And if we find a favorable output, we basically keep going in that direction till either that direction proves to be not useful for us, or if that direction proves to be useful, we find the pattern, we increment the counter, and then we go back. Also, one more interesting fact to note here, the hint 2, and I think the thing that is very easy to miss is that a lot of these characters can overlap. So if you see here, like this M, it is being overlapped by here and by here, and then there are some like this S, which is being overlapped in 3 different patterns. So there is 1, 2, and 3. So whenever we are starting with an X and looking in all 8 directions, it is very much possible that we will probably encounter that again, even on a below element when we start looking at it. So it can come back and it can be a part of some other direction as well. Yeah, and I think we already discussed about how we have to ensure that we don't go out of the bound. So if we are looking at X, this is out of bound, this is out of bound, and this is out of bound for us. So do you think you can write some code for that? Well, I'm going to try doing that right now, but now it's your turn as well. You can pause the video here and try to write the code, and I will push my code on GitHub and the link will be in the description or as a pinned first comment below. But let's write some code. I'll see you in a bit. And we are back, and as you can see, we have solved the problem and we have bagged ourselves 1 gold star. And it took us barely no time. I think within 5 minutes, we were able to quickly write some Python code. And I followed the exact same approach that I mentioned here. Basically, iterate over each character, find the first initial character, look in 8 directions, go on a branch, do a backtrack. And even when you find something, just don't stop. and keep looking, because from one place, as we saw, there can be multiple matches that can come up. And this is done. And this approach, there are a lot of optimizations that we can do, and let me know in the comments if you want me to discuss that. But since the input that was given to us was barely 140 by 140 characters, this was fairly quick to do. So let's move on to the part 2, and I'm sure they will again mess up something and try to change the things for us. So let's read this, and let's make some space before that. So what I'll do is I'll just put this here, and let's write the part 2. Let's pick some other color. So the part 2 says that the elf looks quizzically at you. Is that a word? Quizzically at you. And did you misunderstand the assignment? Looking for the instructions, you flip over the word search to find that this isn't actually an Xmas puzzle. It's an X-mas puzzle in which you are supposed to find the two masks in the shape of an X. Interesting. One way to achieve that is like this. So let me copy this over so that it's easier for us to see. Let's make this white. And of course you can imagine like what is the other way, but like we can read on. And irrelevant characters have again been replaced with dot in the above diagram. Within the X, each mask can be written forwards or backward. And here's the same example from before, but this time all of the Xmasses have, how should I call it? All of the X-masses have been kept instead. So this is the same example that we were looking at. So let's copy this grid here and let's increase the size. Let's use a fixed width font. And as we can see, I think of course there is one pattern which is like this. So if I use my highlighter again, and like we go to this, increase this and reduce the opacity. So we can see that this one follows the same pattern as this one, the one that's here. But we also have the other ones where the mass is going like this, where both the ends are below at the bottom and the S's are on top. It can also alternate between them, so there's an M on the top and below, or it can also alternate where I think both of the M's can be on top. So I think you can see them there overlapping here. So there's one M and two S here, and I think there is another one. So I should use a different color for this. So there's one cross Christmas here, and then there's another one that is here. I think it's pretty more visible. And then there's another one that is here. You can see this gets confusing very quickly. And then we have another one which is here. I hope like using different colors makes it a little easy to understand. So now in this example, the X appears 9 times. So you can see 1, 2, 3, 4, 5, 6, and then I'm sure it's probably continuing like this. 7, 8, and 9. So that's right. Let's go back, increase. Yeah, so we can see that. So we can see that it's appearing 9 times here. So now, before jumping into hints and how we will solve this, I want you to pause the video and think about it, like how the problem has changed when compared to the part 1. And how would you modify the code to solve this, right? So yeah, if you're ready, we can move forward. So I think the initial interesting thing that you can immediately notice is that, so if I delete just this part, that this A is very important, right? Like in all the patterns that you see here, you can observe that the A is the center of the mass word always, because mass can be like this, mass can be like this, mass can be like this, mass can be like this. You get the point. Like A would always be the center. So now think about it, how we can modify the approach. Remember in the initial first part, we were basically hyper fixated on finding an X and then looking at all the neighbors. Can we do something similar, but instead of looking for an X, we can look for an A. And then of course, we don't need to worry about looking in left, right, and up, down. We always look at the diagonals, and each diagonal can basically be of 4 ways. We initially saw that, right? So it can either be like MAS, where both the M's are on left, or it can be both the M's are on top, or it can be where both the M's are on bottom, or it can be where both the M's are on right. Right. Yeah, like this. And yeah, I think this should help you. And once you find a potential center point, it's basically the question of finding that. But remember, we have to be mindful of the boundary conditions here as well, so that we don't get out of the bounds. So I think, yeah, that looks good. Let's write some code. It shouldn't be too difficult. Again, as I said, because the input that we have here, this here is bunch of 140 by 140 characters, which is honestly a lot if you're trying to do something manually, but if you're trying to write some code, it should be like probably sub millisecond problem for us to solve. And especially that now, instead of looking for an X and looking in all 8 directions, we are only looking for an A, and we are looking in potentially 4 directions only. And yeah, another thing to be mindful of is that here also you can see there is a lot of overlapping going on. So be mindful of that, because these X boundaries can cross each other. But if you did the part 1, this should be pretty simple for you to do. So let's write some code. And yeah, do share the code approach, or like if you find like some novel approach here with me, and I would be happy to review it. And we are back. So, oh man, this problem was so humbling. So remember when we were discussing, it took me around 20 minutes to do it, where I spent like 10 minutes scratching my head that what am I doing wrong? Uh, so let me go back to the problem, and I will blur the solution so that you don't see it. But yeah, if you see this example here, I think they deliberately give you a cross mus example, and I think doing these crosses here for so long, like I think here we were doing bunch of crosses, and here I think it's somehow registers subconsciously in your mind that that is how a cross can be made. But I think the most interesting line is here, which says one way to achieve that is like this. So I think when we were discussing, I think the ways here, we miss one very important way. And I think to give you the best hint I can, I actually, after I solved it, I looked up at the subreddit, and I actually found this post. So this meme should explain it really well to you. And I also posted a comment that found it by a mistake, and plus is equal to cross in some world, and assumption skill 101. And that is very interesting. So to explain it further, so if you look at this here, so we were assuming that we can only make, so let me decrease the width. Let's take some other color like this. So we were assuming that we can only make Christmas like SAM, SAM, and then all 4 variations where I will have 2 M's on top, 2 S on below. And then there was another 2 variations where you will basically have 2 S on top and 2 M below. And then there is another variation where we have 2 M's on left and 2 S's on right. And if you see, like, they all spell Christmas. But one thing that we missed is that the same thing can be created like this as well. And if you think like the plus is just a cross, you just have to tilt it by 90 degrees, and which meant that there is also like cases where we can make SAM, SAM, and then you get the whole deal, right? Like it can be MAS and then MAS similarly. So SSMM. So we can have SAM and then SAM, and then we can have MAS and SAM. And if you look at this, this also makes like a Christmas. So anyways, I hope you found this helpful. I have written the code. Unfortunately, since I was experimenting and I got stuck, it's a lot of spaghetti code. So I'm going to write it again in a more clean manner so that it's easy for you to understand. And yeah, I'm very excited. Let me know how much fun you had solving this problem. And I will see you tomorrow at same time for the day 5. All the best and see you later.